Good day to everyone. My name is Lowen Song, and today I will be doing the recording for this recording is for the presentation of the report from the course of SDQM 6154 Network Science. My name is Lowen Song, and my lecturers are Associate Professor Dr. Fatima Abdul Razak and also Dr. Sakina Abu Bakar. Okay, so my in this presentation, first of all, I will introduce to you my network, the data set that I'll be using, some knowledge about it, and then I will visualize my network to you, and I will also describe some of the architectures, such as the vertices and also the edges, and how are they decided from to form the network, and also what do I want to achieve with this by turning this data set into the particular network. Okay, so and then after that I will be describing to you what are the important findings from my report. So for the data set, I'm using the data from the 2010, the year of 2010, People's Republic of China's population consensus, published by the National Bureau of Statistics by the country. And this data basically captures the phenomenon of population flow, or I call it as population migration. Okay, so the reason why this data set can be useful is because in China there is such a thing called hukou system. Hukou is basically decided when you're born, right? Let's say when you are born in one province, you are registered as a permanent resident of that address. Okay, so when that address lies in one province, and then afterwards when you move to another province, may it be with your parents or maybe because you grow up and you move to another province. So when this deviation happens, it's called a separations of Foucault. Okay, so and this allows us to understand why where what are the migration patterns of population in China. It's like how much people want to move away or move to a particular province. Okay, so to process my data, I will be using min-max normalizations to standardize the metric to read my whole data, and then I will be using RStudio to present my network and every findings that I find after this. Okay, so this is my network, and basically you can see that it is not a regular graph. This is because I modified the architectures before presenting it as a network. Essentially, in order to describe the relationship, which is the edges, this is clearly a directed graph. So in order to define how are these directed edges defined, I define it based on whether the migration is significant enough, and this is decided if the value of the normalized value exceeds, which is greater than or equal to 0.15, I count it as significant migrations. Okay, so of course the inward direction will be the immigrations and the outward direction will be the emigration. So what do I want to achieve with this model? Essentially, by turning this data set into this model, what I want to do is I want to leverage the tools from network science and to carry out certain analysis to find out what are the factors that motivate migration patterns across China up until the year of 2010. Okay, so I will be using things. I will be using measures such as centrality measures, models comparison, distance, MST, and degree distributions, etc. But I digress, as that is from the report itself, and this presentation is mostly about the findings. Okay, so my first finding is that I find out that when doing the centrality measurements, I use four different centrality measurements: degree, betweenness, closeness, and also eigenvector. I find out that all of my centrality measurements point to the province of Henan as the key player in my network. And this actually deviates from the conventional expectations that we would have from real-world migration dynamics. What I mean is that when you think of people moving from one province to another province, what are the reasons? Most of the times, it's motivated by career opportunity, or it's motivated by how much they want. What are the how high of an economic activities in that particular province is, so that they have of course better career opportunity. And but then Henan is actually somewhere around the middle between the 31 provinces, the 31 vertices. Henan actually lies around somewhere in the middle, around like 15 or 14, yeah, somewhere around there in terms of GDP output. So why is the Henan pointed as the key player throughout all of the four different centrality measurements, and um, and this is what I want to produce. In my first finding, what I hypothesize is that it could be because of the between centrality and also closest centralities also point to Henan as the key player. We can hypothesize that maybe it is the spatial influences or the proximity of one province to other provinces could be at play at what influence or motivates the migration pattern, maybe emigrate or immigrate, essentially just migration patterns across the country up until the year of 2010. Okay, so in my second findings, I find out that when I compare my network using these three metrics, which is the average path length, clustering coefficients, and also degree distribution, I find out that my network resembles that of a small world network. Essentially, what this would imply is that my network has a relatively healthy migration pattern because a small world network has a binomial degree distribution, as you can see from my result here. So my original network degree distribution and also the from the small world at revariant probability of 0.05, you find out that they are very similar in terms of the way the degree is distributed, right? Whereby most of the provinces have around the same degree with some outliers, of course. And so we can also look at the clustering coefficients and also average path length, and you notice that our original value for these two metrics are very similar to when the probability of rewiring is at 0.05. Okay, so yeah, what are my last findings? My last finding is that if we remove the degree influences, what are the other factors that could be at play at influence this is basically the climax of my report, which is I find out that maybe it is the closeness of provinces that could affect or influence the migration patterns across the country. Okay, by using Levene algorithm, I will as a community detection algorithm, I will find out the structure, the underlying structures and relationships based on the connectivity patterns alone, like without caring about the degree. Okay, and I actually find out that you can actually see that the communities are well separated into what we would see in real world of how provinces are separated in terms of geographically. Okay, so the cyan one would describe the northwestern part of China. The yellow community would be from the central to far north of the country, and the red one is from central to general south of China, while the green one is the southwestern part of China. And from here, we can actually understand why Henan has such a high value of closeness and between centrality. Is because Henan acts as the hub that acts as a bridge to connect different communities. Okay, and that's why it has such a high centrality values. Yeah. Okay, so in conclusion, my centrality measurements consistently identify Henan as a key player in the migration network. Okay, and which suggests that there are underlying factors influencing the migration patterns beyond what we would conventionally think of as motivations. Okay, so which lead to the hypothesis of spatial influences. And with that, I also found out that by comparing my network with different models, it indicates that our migration network aligns with the characteristics of a small world network, whereby there exists a even spread of migration patterns with some notable outliers. Okay, lastly, the application of a community detection algorithm, specifically the Levene, it further supports our first hypothesis that the spatial distribution of provinces significantly influences migration patterns. Okay, this is because our community detection algorithm delineates different regions of China as distinct communities, and it actually accurately captures the provinces' corresponding spatial positions, even without these explicit geographical informations embedded into the dataset that we use to generate our data. Yeah, so that is all from my findings, and thank you for listening.